And for the next example in our notes, and yeah, that takes up a lot of room. So the next example, I'm going to move this up so you can see here. The next example in our notes, I think I can make it fit right here where I've got a little bit more space. I just don't want you to start it down here and then run out of room. So if you don't feel like you have enough room, you can turn to the back. So the next example is 636 divided by 16. Some people are like, what? That's weird. Yes, this is an improper fraction, meaning that the numerator or the top number is bigger than the denominator, the bottom. Improper fractions, I tend to abbreviate IF just because that's the abbreviations for improper fractions. So with that, we need to divide 636 divided by 16. I want to leave 2 lines here to give our answer. So on this line right in here, the third line down, I have 636 inside divided by 16 on the outside. I'm going to change colors. I need to put a place value over the 6, the 3, and the 6. And now I'm looking at, okay, I've got to divide how many groups of 16 go into 6? Well, none. 16, how many go into 63? And you could look back up in our work we showed up here because we were using 16. 16 times 4 was 64. It was too much. We have to get 63. So I know it's going to be 16 times 3, but I need to show that work to the side. What is 16 times 3? And I've got room, so I'm actually just going to show it right here. 16 times 3. 3 times 6 is 18. Carry the 1. 3 times 1 is 3, plus 1 is 4, so I got 48. So the 3 goes there. 3 times 16, I'm going to write 48 right here under the 63. Subtract, trace the blue line. So if you can't count up, you might borrow. 6 becomes 5, and then 3 now becomes 13. Trying to write my numbers nice and neat so you can read that. 13 minus 8 is 5. 5 minus 4 is 1, and you need to bring down this 6. How many groups of 16 go into 156? Well, I know just looking up in my examples we did up above, 7 was 112, so we're probably going to need more than that, and I will help you. It's going to be 9. 16 times 9, I'm going to use this space to show my work. 9 times 6 is 54. 9 times 1 is 9, and when I add 5, I get 14. So now I need to put a 9 above the 6. 9 times the 16 we had was 144, so I need to write that down here. Now I'm ready to subtract and trace the blue line. Move this back up a little bit so you can see. 6 minus 4 is 2. 5 minus 4 is 1. Now see how I have nothing else to bring down right now. So what I'd like to do is I'd like to circle this. This is my remainder. Now what I did on the last problem, I rewrote the whole number 39 and I made a fraction and I bring this 12 and I bring it up on top of the fraction. 12 goes on the top over what I'm dividing by 16 on the bottom, and that is not simplest form. 39 and 12/16, that fraction can be reduced. You could divide by 2, but then you're going to need to divide by 2 again. You could also divide both of these by 4. So if I redo that, this answer ends up being 39, and 12 divided by 4 is 3. 16 divided by 4 is 4. So 39 and 3/4 ends up being my whole number with the fraction. We call that a mixed number. Now I'm not done because I still need to express this part as a decimal. When I go back and I want to use the black pen and I'm going to put a decimal in the problem and a 0. You always add those to the problem first. The decimal goes straight up in your answer, straight up to your answer, and you put a place value holder above that 0. This 0 comes down into here. So now you have 120. How many groups of 16 go into 120? And you can look back up at all of our work to see which one's close to 120 without going over. And it should be 7 because 7 gives you 112. So you need to write 7 above this 0. 7 times 16 was 112, and you write that down here below the 120. Now you're ready to subtract, trace the blue line. I can count up from 112 to 120 and I get 8. And I am not done because I have to add another 0 to the problem. another place value, bring this 0 down, and I have 80, and we've seen 80 before. That's how we ended the last problem. And what was our, yep, right there, 16 times 5 gives us 80. So if we put a 5 above that 0, 5 times 16 gives us 80, and we subtract, we are done. We have ended with 0, and that's good. So what are the two answers that you could say you get in this problem? You could say 39.75 or 39 3/4. They are the same answer, the same number on the number line. One is just decimal and the other is a fraction form. I would like to add a few terms to our notes as well. And again, if you don't have room, you can go to the back of your page. But we have two terms that I want to talk about. The first one is a repeating decimal. And I'm going to write that in blue. I'm going to box it in with the other color black. What is a repeating decimal? It's something that goes on forever. Examples of repeating decimals, sometimes you get something that doesn't, it just keeps going on, like 13.33333333 or something that goes on forever. So a repeating decimal goes on forever. And nobody wants to write, 13.33333333. So there's a way you can write it. For example, if I had 13.333333 and I get tired of writing that, there's a way to show it. I can just write it as 13.3 with a line over the 3. That line means that this 3 repeats on forever. And I can write it like that. Another example you might see, I'll put another example here. What if you see like 14.45, 45, 45, and that 45, 45, 45 keeps repeating? You could write it as 14.45, and now the line has to go over both the 4 and the 5 because the 4 and the 5 continuously repeat. It's not just one number, it's both. So those are examples of repeating decimals and how you would write those. Maybe kind of box those in to keep that with repeating decimals. The next term that I have is called terminating decimal. And that is like the ones we had in our examples today. A terminating decimal means it comes to an end. It finally ends. Sometimes it'll terminate one place after the decimal. Our example here, it went 2 places after the decimal. Our example up here, it went 3 places after the decimal. So a terminating decimal means it will end. So I'm going to write it ends. And you could just write our examples we had here. We had 47.625, or in this example we had 39.75. They ended. The homework that you're going to practice for dividing with remainders, I'm going to write HW. It is a worksheet. It's actually the back of your division worksheet that you did, so it's on the back of your division worksheet. You are going to do 6 division problems, and they're with remainders. All of them will have remainders. So remember, I want you to express your remainders as decimals and fractions, just like we did here in our notes.